Okay, this is the next lesson in Algebra 2 in Unit 5. It is Lesson 2, Multiplying and Dividing Radical Expressions. Okay. So, the first property that you need to know is called multiplying radical expressions. If the nth root of A and the nth root of B, notice how the index is the same, if the nth root of A and the nth root of B are real numbers, then the nth root of A times the nth root of B equals the nth root of A times B. Okay? So we're going to apply that to example 1. Okay? We have the square root of 2 times the square root of 8. The square root of 2 times the square root of 8 can be thought of as the square root of 2 times 8. Okay? Now the reason why this comes in handy is because the square root of 2 is not a nice number. The square root of 8 is not a nice number. But when you combine them, you get the square root of 2 times 8. In other words, the square root of 16, which is nice because it's just 4. So that's the answer. So this property does come in handy, as you just saw. Simplify if possible. Okay, again, the index is the same or else you cannot do this. But we have the cube root of -5 times the cube root of 25. So this is going to be equal to the cube root of -5 times 25, which is the cube root of -125, which equals -5, because -5 times -5 times -5 is -125. Simplify, if possible, the square root of -2 times the square root of 8. This one cannot be simplified because if you notice above, it says if the nth root of A and the nth root of B are real numbers, the square root of -2 is not a real number, it's imaginary, so the property does not work. I'm going to write that out in words. The property for multiplying radicals, the property for multiplying radicals does not apply since the square root of -2 is not a real number. Okay, on to the next page. Simplify the expression, the square root of 72x cubed. Assume that all variables are positive. Therefore, absolute value symbols are not needed in the simplified expression. So in lesson 1, we learned about when you have to include absolute value symbols. But now the problems are saying just assume that they're all positive. So you don't have to include absolute value symbols for the variables going forward. Okay? Okay. So some of this is review. Okay, so I think this one and the next one are kind of review, but that's okay. Simplify the square root of 72x cubed. You can think about that as the square root of 72 can be broken down into the square root of 36 times 2 times x cubed. Okay, and again, I like to break this apart a little bit more. I like to put square root of 36, square root of 2, square root of x cubed. Square root of 36 is 6. 2 stays under the square root. For x cubed, you're looking for groups of 2 because that's the index. You can take out one group of 2. And what's left over under the square root symbol is the 2 and 1x. because we took out a group of 2. Again, absolute value symbols are not needed for this lesson because we're assuming everything is positive now. We learned about when to take out the absolute values in the first lesson. So that problem is a review from lesson 1, mostly. This next problem is also a review. Simplify the cube root of 80n to the 5th power. I'm going to break that down into square root of 8 times square root of 10. I mean cube root of 8 times cube root of 10. Again, I like to do this. I like to rewrite it like this. I like to break it apart more. Cube root of 8, cube root of 10, cube root of n to the 5th. Why did I choose 8? Because I know it's a perfect cube. What are perfect cubes? 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. So again, I used 8 because I know 8 is a perfect cube and it's a factor of 80. That's why I rewrote 80 as 8 times 10. But at this point, I can get to my final answer. The cube root of 8 is 2. The cube root of 10 is going to stay. The cube root of n to the 5th, you're looking for groups of 3. You can take out one group of 3. What's left over is the cube root of 10. The 10 is left over, and we have 2 n's left over. Example 6, multiply and simplify. Okay. Well, when you multiply them, you get the following. You get the cube root of, sometimes it's easy to multiply them together, and sometimes it's not. Okay. In this case, 54 is hard to simplify with the perfect cubes above. 5 is hard to simplify with the perfect cubes above. But if you combine them, 54 times 5 is 270. X squared times x cubed is x to the 5th because you add the exponents. Y cubed times y to the 4th is y to the 7th because you add the exponents. Okay? And now again, let's think about our perfect cube numbers. 1 times 1 times 1 is 1. I'm just going to rewrite this again. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. 6 times 6 times 6 is 216. I'm going to stop there. And I know that 27 is a factor of 270. So I'm going to do this next. I'm going to put the cube root of 27 times 10 times x to the 5th times y to the 7th. And again, I like to break this apart more. You don't have to do this if you don't want to. I like to rewrite it like this now. I don't know. I just kind of like it doing it like this. The cube root of 27 is 3 because 3 times 3 times 3 is 27. The cube root of 10, that's going to stay under the cube root. The cube root of x to the 5th, you're looking for groups of 3, and you have 5 x's, so we can take out one group of 3. And for the y's, you're looking for groups of 3. We got 7, so you can take out 2 groups of 3 for the y's. What's left over under the radical will be the cube root of 10 stays. We took out 3 x's, so that means there's 2 x's left over. We took out 6 y's, so it means there's 1 y left over. Okay. Moving on to the next page, we are going to use this property for dividing, okay? If the nth root of A and the nth root of B are real numbers and B is not equal to 0, then the nth root of A divided by the nth root of B equals the nth root of A over B. Now you'll see why that comes in handy in this example right here. But you may think that these are not real numbers because you have that -4 right there. But these are real numbers because you can take the odd root of a negative number. Let me jot that down just so that way you know why I'm doing that. You can, okay? You can take an odd root of a negative number. Okay? We talked about that before, and you'll see why once you do this example out. But you can take an odd root of a negative number. Okay? You can. So the cube root of 32 divided by the cube root of -4. Now this is, you cannot easily get the cube root of 32. You cannot easily get the cube root of -4. But if you combine them into one, the cube root of 32 divided by -4, and then you do 32 divided by -4, you're going to get the cube root of -8. This you can do easily. You can easily get the cube root of -8. What number times itself 3 times equals -8? The answer is -2. Example 8, divide and simplify. Again, assume all variables are positive. So let me just recopy down the problem first. This is not an easy lesson, by the way. This entire unit is not that easy. I just want you to know that. It is not an easy unit. It is Algebra 2. It is not everything's easy. I'm going to write this as 1. 162 x to the 5th divided by 3x squared. 162 divided by 3 equals 54. I'm not sure if you remember this from Algebra 1, but when you divide with the same base, you subtract the exponents. So x to the 5th divided by x squared is x cubed because you subtract the exponents. Okay? Let me explain why. So just to show you that x to the 5th divided by x squared. This is what I did. Okay, I'm just doing it off the side to show you again. This equals x to the 5 minus 2 equals x cubed. If you think about it, it makes sense. X to the 5th divided by x squared. This is what we basically did. So this x divides out with this x. This x divides out with that x. So you're left with just 3 x's. That's why you subtract the exponents. Now we have to simplify this. Okay, so again, perfect cubes. Let me just make a list over here. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3 is 27. Bingo. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. Break apart 54 into 27 times 2. Like this. And again, I just like to rewrite it like this. Cube root of 27 times cube root of 2 times cube root of x cubed. The cube root of 27 is 3. And we're going to take out, we need groups of 3. We have 3 x's, so we take out one group. And what's left over under the radical is just the cube root of 2. Remember, the radical always goes at the end, all the way to the right. Okay, let me just recopy down this problem for example 9. I'm going to rewrite it as 1. 1024 x to the 15th divided by 4x. 1024 divided by 4 equals 256. X to the 15 divided by x to the first power, subtract the exponents, you get x to the 14th. Okay. Now this time, we're going to do fourth roots. Okay. Because our index is 4. 1 times 1 times 1 times 1 is 1. 2 times 2 times 2 times 2 is 16. 3 times 3 times 3 times 3 is 81. 4 times 4 times 4 times 4 is 256. Oh, nice. Okay, so the fourth root of 256 is just 4, because 4 times 4 times 4 times 4 is 256. So if you think about it, this is going to become 4. Looking for groups of 4 for the x's, we got 14. So I'm going to take out 3 groups of 4. And what's left over is 2 x's. Okay. Last page. Rationalize the square root of 2 divided by the square root of 3. Now, I'm not sure what you remember from Algebra 1 and geometry, but there are no radicals allowed in the denominator of a final answer. Let's jot that down. No radicals allowed. No radicals are allowed in the denominator for a final answer. So here's how we are going to rationalize. The square root of 2 divided by the square root of 3. Rationalize. What you're going to do is you are going to multiply by whatever this is over itself, like the following. You're going to do times square root of 3 divided by square root of 3. The reason why you're doing that is because that is going to eliminate the square root in the denominator. Because if you think about it, your numerator is square root of 2 times square root of 3, which I'm going to write as square root of 6. Your denominator is the square root of 3 times the square root of 3, which equals 3. So no more square root in the denominator. No more radical in the denominator. Because the square root of 3 times the square root of 3 is the square root of 9, which is just 3. The square root of anything times the square root of itself is just what's under the square root without the square root symbol. So square root of 10 times square root of 10 is 10. Square root of 55 times square root of 55 is 55, and so on. Let's do the same thing for number 11. We have the square root of x cubed divided by the square root of 5x. We are going to rationalize by multiplying by square root of 5x divided by square root of 5x and the y. Don't forget the y. So here's what I get. In the denominator, the square root of 5xy times the square root of 5xy is 5xy. No square root symbol. My numerator, I get the square root of 5x to the 4th power because you add the exponents when you multiply, and then y. And then you can simplify the square root of x to the 4th, because the square root of x to the 4th is x squared, and you're left with 5y under the radical divided by 5xy. And then you can simplify more. You can divide out one of these y's you can divide out one of these x's with one of those x's to get the following: x times square root of 5y divided by 5y. Last problem, rationalize the cube root of 2 divided by 3x. So first things first, I'm going to separate this. I'm going to rewrite this as cube root of 2 divided by cube root of 3x. And now think about it like this. If this was a square root, I would just have to multiply by square root of 3x over square root of 3x. But it's not, it's a cube root. So what I have to do is I have to multiply by the cube root of 3x divided by the cube root of 3x, and then times the cube root of 3x divided by the cube root of 3x. If that was a 5, I'd have to do that 5 times. This one and then 4 more. If that was a 10, it'd have to be 10 times, and so on. But by doing that, I get the following. My denominator, the cube root of 3x times the cube root of 3x times the cube root of 3x is just 3x. My numerator is the cube root of 2 times 3x times 3x, which equals the cube root of 18x squared. Then you'd want to see if you can take out anything, like is there a perfect cube that's a factor of 18? No, because you have 1. That's not a factor of 8. Oh, it is, but you can ignore 1. 8's not a factor of 18. 27 is not because it's bigger. So you cannot simplify the cube root of 18, and you can't take out any groups for the x's, so I'm going to leave that as my final answer. That was a difficult lesson. I'm not going to lie. That was not easy. But that lesson was called Multiplying and Dividing Radical Expressions.